Hello, everyone. Our research is cross-domain ontology construction and alignment from online product reviews. I am the presenter, Deng Siyu, from Beijing Normal University. The authors of our article is Geng Chen, Deng Siyu, Jia Danping, Jun Jian. The context of our research is about 4 parts. First one is the research background, second one is the related work, third one is the research methodology, last one experimental study. Let's look about the first one of research background. As we all know that the commercial website development have increased to change our daily life. The Amazon, Taobao, the consumer will express opinions on different aspects of product. So if the reviews can be organized structurally, some problems encountered by consumer may be partial is. Then we know that ontology have been researched for so many years. The organization of product reviews by using ontology will help consumer to better access the information and provide support for the research decision making. So the first research question is about how to leverage the cutting edge techniques to construct ontology from online product reviews. And the second research question is how to build a solid approach that is able to align ontologies that are built from a large volume of online product reviews in different domains for product comparison. Let's look about our contribution. Firstly, the framework is proposed to facilitate consumers to leverage valuable online opinions for cross-domain product comparison in research making. Secondly, combine with feature words and sentiment words identified from product reviews context. Thematic relations are identified to discover non-hierarchical relations between entities for ontology construction from different domains. Thirdly, a new approach that reckons the semantic-based similarity and structured-based similarity is proposed to improve the performance of ontology alignment to support cross-domain product comparison. Let's look about the second part is related work. Up to now, there is so many research about product comparison, ontology construction from text, and ontology alignment or ontology mapping. So a brief summary is that some multiplex non-hierarchical relations are ignited in this research, and mainly existing ontology alignment method reckons the semantic similarity between entities only, which causes the bad result of ontology alignment. So let's look about our research. About our research methodology, first part is the problem statement. The core of our study is to how to construct an ontology from online product reviews and how to align ontologies that are constructed from context in different domains. It aims to facilitate the consumer to make a comparison and a research decision for cross-domain products by analyzing a large number of online opinions. Specifically, at first, text proposition tasks are contacted to get product feature word and associated customer sentiment words. Then, the identified product feature words and associated customer sentiment words are used as a class and the relationship between the class for ontology construction, or as an individual to fill the constructed ontology. In addition, semantic relations between entities are used to uncover invisible non-hierarchical relations between product feature in reviews text. Finally, ontology alignment aims to leverage a large volume of online opinions in multiple domains and provide consumers with illustrative product comparison results. So let's look at the framework of our research. As the picture shows that our framework is divided into 3 parts. First one is corpus preparation. Second one is ontology construction. Third one is ontology alignment. Let's look at it in detail. In the phase one, corpus preparation. As we choose in this as raw data, we choose amazing of the reviews about in electronic too, and Apple's iPhone and solid digital cameras are recognized as exemplary products. Next, a series of proposition tasks are conducted, such as word tokenization, stop word removing, sentence segmentation, punctuation mark elimination, pure tagging, and normalization. Pros and cons list of products in cnet.com are utilized to identify product feature words by analyze frequently appear norms, and those norms are regarded as product feature words. Also, objectives and other verbs that modify the product feature words are regarded as customer sentiment words. The dependency relation of predict by syntactic parsing is asserted to mirror no hierarchical relations and other relations. Let's look at some exemplary sentiment words. We divide this sentiment dimension into 5 parts about strong positive, neutral, and negative, strong negative. This sentiment word is proposed from the NLP techniques and from this product reviews. Let's look about some exemplary product feature words. We also divide the feature word into different dimensions, such as external feature, internal components, and so on. Then, let's look about the second part of ontology construction. First, CVC class method is adopted to identify the prepositive relations of is-a relation. Then, some triplets are predefined as training data to identify the non-hierarchical relation. At the same time, a feature product description is individual as background knowledge for pre-definition of triplets. Such background knowledge can be Wikipedia, product information, professional knowledge. Let's look about some predefined triplets. The formation of these triplets is head entity, relation, and tail entity. We can find that different head entity and tail entity refer to this feature word in the product. Then, let's look about the second phase. Next, the corpus obtained from propositions task contains a large number of duplicate and inverted entity. Syntactic we construct the entity recognize and relation extragation from by implement the transaction algorithm to. So about the transaction algorithm. Let's look about first about the TransE. From the left picture, in the left picture, we can find a TransE model have the H refer to the head entity, T refers to the tail entity. The two entities can be connected by the R about the relation with the lower arrow. So transaction algorithm model a relation as a higher plane together with our translation operation on it. Let's look at the picture in the right part. We can find that the black line H and T with this red line H and T have the same projection on the WT hyperplane. So we can define that the two pair of entities have the same relation. Let's go on. About the last predefined XML framework is applied by ontology parsing to facilitate the import of external or entities relations. Such this feature word and sentiment word pair in ontology corpus is an individual for knowledge filling. In this study, OWL is import for ontology parsing and importing, which can be visualized by Portage. So an example about the construction of smartphone domain ontology in Portage is illustrated in the picture. We can find that in the smartphone have different category, like internal components, internal information, internal function, external feature words, and so on. Each different categories have different subclass we can find in this picture. Then let's look about the phase 3 of ontology alignment. Both semantic-based multi-vec algorithm and structure-based no-to-vec algorithm are integrated to estimate the similarity between entities for better alignment mapping result. First, the stable model in multi-vec algorithm is selected to contact the sentiment and the semantic-based similarity. We can find this from the picture that when we input several words, we can predict the word based on the context word. Then, meanwhile, the no-to-vec package in Python is utilized to implement the no-to-vec algorithm by taking representation of nodes in graph structure of two construct ontology as input. As by adapting no-to-vec algorithm, a dense vector can be learned for each entity. Let's look at the picture. We can find that in no-to-vec, the weighted random walk algorithm is applied to construct several linear sequences, and different special work is more inclined to DFS or FS is evaluated by the different situation. Then, with a vector precision of entities, the tester to estimate a confidence value. Considering the similarity assessment between entities occupies an equal important proportion, the aggregating weight is 1 divided by h, which implies the average of similarity measures. The formula is as follows. For each measure, the cosine similarity is applied to estimate the confidence between a pair of correspondence. At last, those pair of correspondence with a higher confidence are left in the final alignment result, which indicates the equal to relation between each two entities. Let's look about the first part of experimental study. First, let's look about experimental 1, the evaluation measure. In OAEI ontology mapping campaign, the alignment systems are compared to use precision, recall, and F measure. Precision is a percentage of corrected discovered alignments in all discovered alignments, and the recall is a percentage of corrected discovered alignment in all corrected alignments. And the F measure is the harmonic mean of precision and the recall. Then we can get some evaluation result. The proposed approach is benchmarked with YAM++ for ontology alignment of two domains, that is smartphone and digital cameras. Some example is shown in the table 4. And combined with domain ontology as well as background knowledge, whether a found alignment mapping is correct to find mapping is indicated in this table. For this table, we can find that some word like the real camera and the camera bike. The two is not the right collection, not the right mapping, but the YAM++ will get a higher similarity result. That's absolutely the wrong mistake, it's the wrong result. And then our proposed method is benchmarked with another 4 ontology alignment tool: COMA, YAM++, Falcon AO, and STROMA. In this picture, we can find that the proposed method could achieve a higher recall and higher F measure, even though it's not the highest precision. It's only the second higher of the precision just behind the STRMA, but it can achieve the highest F measure among those alignment tools. Besides, the proposed method is compared with different alignment tools in the terms of execution time, which is shown in the picture. We can find that we can find this from this figure that the proposed method is cost a little much time. So it's enlightened that in the future some manipulation and adjustment need to be conducted to improve the performance by reducing the runtime. Let's look about experiment 2 or case study. Considering of the structure and data size of construction size, the visualization in Protege is not well enough for the users. So to provide a better user experience for ontology visualization, an external website was built. Take two type consumer digital products, that is mobile and camera, as a concrete example. It aims to pinpoint practical applications of ontology alignment from different domains. First, the website utilizes versal switches in each chart for chord diagrams and force-oriented diagrams. About each chart is come from the visualization platform of Baidu. Let's look about the figure 5. In the figure 5, it shows the domain ontology in the chord diagram. In the diagram, users can use a mouse to choose the cycle of a different color. It stands for a different class and entities. And the line in the two different cycle, it will show the different relation between the two entities. So the users can choose what they want to see in a different color, and then when the users click this button, it can change to the force-oriented diagram. The force-oriented diagram is like this. The users can use the mouse to drag. Users can place the mouse on any cycle to display the class name of class, and he or she could freely change the arrangement and the rendering position of the parent class and the child class by dragging any cycle according to he or she's personal needs. Then, the core of the website is to enable potential customers to compare products of different domains for purchase decision in two aspects. First one, fine-grained customer sentiments are related to a particular product feature in different domains can be gained. Second one, sentiment comparison on particular feature of the products in different domains can be made. First, give a feature word in the search box. The website helps customers to retrieve corresponding fine-grained sentiment word in different domains. For example, with a user input screen, sentiment words that are highly corrected with the feature screen are presented. As this picture, you can find that when the users input the screen can get a different type of sentiment dimension, and compared with smartphone and digital camera, we can find that different dimension words have different sentiment words responding with different aspect. Then, users give a feature word in search box, and the website helps to compare products on this particular feature. For instance, if a user still uses screen, we can find that from the smartphone and digital camera with different brand model, such as in smartphone, there are iPhone 5C and 5S have different sentiment words with this feature of screen. And in the digital camera, with the Sony A330 and the Sony A390, it still have some different sentiment word about this feature word of screen. So let's look about the conclusion. Firstly, in a study, NLP techniques and translation algorithm applied to construct ontology from online product reviews. And a new approach of ontology alignment is proposed, and the construct of cross-domain ontologies is for the product comparison. In the future, it is essential to optimize the strategy, and we can explore more relation besides equal to relation. At last, it's also of great significance for product marketing to explore the interaction between different products, such as complements, supplements, competitors, and the main products and accessories. That's all. Thanks.